and welcome back to Strive Academy's virtual STEAM activities. It's Monday morning. We are on week 8, I believe, which is kind of crazy to think that we've been home for this long, but we hope that you're enjoying our activities. We hope that you're checking out our website, www.striveacademy.org, where you can find all of the activities that we've been doing this whole time. You can go back and try some of the ones that you've missed. Today we're doing a really simple science investigation, but it's a great opportunity to form a hypothesis, test some different things, and come to a conclusion. Today we're going to look at how different surfaces affect the rate at which ice melts. So all that I have today is I have 4 pieces of ice in here, and I just have 4 different surfaces. You could pick anything that you wanted. I chose a paper plate, a Tupperware, some foil that I just folded in half, and some parchment paper. So you could use saran wrap, you could use a regular plate, you could just use your table, you could test this on any surface that you can think of. And quite simply, what we're going to do is just put the ice on these different surfaces and time how long it takes to melt. So today for the title, it's When Will It Melt? And for the hypothesis, what I want you to do today is look at the different surfaces that you chose, and they might be different than mine, and pick which one you think will help the ice melt the fastest. And if you want to maybe take this a step further, you could say, okay, I think the ice will melt the fastest on the paper plate, and I think it'll melt the slowest on the foil. Or you could rank whatever surfaces you're using and list them in order from fastest to slowest. Whatever level your child is at, or however long you want this to take, you can definitely do different things with your hypothesis. For your design, I want you to just sketch out what it looks like, just what your experimental setup is going to be. So what I would do is I would draw these 4 surfaces and label them, and then show a piece of ice on them, on each of them, to show what my setup's going to look like. And again, I have been saying this the whole time, no matter how simple the experiment is, it's always important to have an idea of what you're going to do, so that you're not just jumping in and wasting materials and making a mess, but that you have a plan. And so drawing it out, or at the very least writing it out, is really, really helpful. When you're ready to start your experiment, you're going to lay out your surfaces, and when you're ready, very simple, all that you're going to do is put a piece of ice on each of your surfaces. And again, I have 4, you could do 2, you could do 20, it's totally up to you. And you're going to start your timer, and just let it start going. And so the goal would be that you can just have one timer, and that you can then stop and record the times at which they melt. So this might be something that you walk away from for a few minutes and come back to. Under data collection and observation, we're going to try to make some really good observations today. So what we've asked you to do is every few minutes, and maybe just set your timer for 3 minutes, and then 2 more minutes to get to 5, and 2 more to get to 7. But every few minutes, just stop, observe your pieces of ice, like I would observe my 4 pieces of ice, and draw a picture, or if you're older, write down what it looks like. So we're making observations about what's happening to the ice over time, and hopefully it's going to look different on the different surfaces because they're going to melt at different rates. So that would be pretty cool. Under results, we're going to, at the end of this, record how long it takes for each piece of ice to melt. So it might be 2 minutes, it might be 10 minutes, it might be 20 minutes. Who knows? This is a cool investigation that we can find out. So again, you can kind of take this to the next level if you want. It's very simple, but you can add lots of other pieces to it, or you can keep it very, very simple. For the analysis questions today, they say, on which surface did the ice melt the fastest, and why do you think this happened? And on which surface did the ice melt the slowest, and why do you think that happened? So really looking at, why did this surface melt it faster than this surface, or slower? And then how could you redo this experiment to make it more scientific? So the goal here is that the only variable or change between each setup is the surface that it's on. But you might not think of things. Like maybe your ice cubes are a different size, or maybe the person who started the stopwatch didn't start right on time, which is fine, but how could you make it more scientific? And then finally, if you want to try some extensions, you can obviously try as many different materials as you want, but maybe even try different temperatures. So for example, instead of doing 4 different surfaces, you could have 3 different paper plates. You could put one of the plates in the freezer for maybe 20 minutes before you start. Put one of them in the microwave for 10 or 20 seconds before you start. So now you have a cold surface, you have a room temperature one, and you would have a warm one, and see how temperature affects the ice melting. The other extension we have today is this all has to do with heat transfer. So how heat is transferred from one object to another. And there's 3 different types of heat transfer: conduction, convection, and radiation. This particular experiment has to do with 2 things touching. The ice is actually touching the surfaces, and so heat is going from the surface to the ice, melting the ice. Now, depending on which surface it is, depends on how long that takes. So our extension is do a little bit of research on conduction, convection, and radiation, and determine for us which type of heat transfer it is. And we'd love to hear your answer to that. And of course, all of your pictures on our Facebook page. Tag us with the hashtag STEAM with Strive, and have a wonderful day, and we'll see you guys tomorrow. Bye.